This is properties of quadrilaterals, which can be found in 5.5 in your books. Quadrilaterals, so it means that all the figures we're going to be looking at in this are going to be four-sided figures, and you're going to be coming up with properties for each individual type. Sounds more intimidating than it is. Don't worry, there are no theorems or definitions. When you do this for your project, you can just put like rectangle and put all the properties of the rectangle on one card. So let's get started. Our objectives. Now we are going to be identifying some properties of parallelograms, rectangles, kites, rhombuses, squares, and isosceles trapezoids. So these are going to be properties that you're going to use to prove these particular types of quadrilaterals. So just keep in mind though, some of these share properties, like rectangle is a parallelogram. So everything from parallelogram will be able to apply to rectangle and has to be true. So let's look at the properties of a parallelogram first. Opposite sides are parallel by definition. So PL is parallel to AR and PA is parallel to LR. So these opposite sides are always going to be parallel. They're also congruent. So we can say that PA is congruent to LR and PL is congruent to AR. Opposite angles are congruent. So angle P is congruent to angle R and angle A is congruent to angle L. The diagonals bisect each other. Okay, so if you have this and you need this in here for maybe to prove triangle congruence, go ahead and put a point there and name it. And then you could say like PX is congruent to RX, AX is congruent to LX. Okay, see how that works? And any pair of angles are consecutive angles are supplementary. So if I took angle P, the next angle, consecutive angle would be A or L, and it's supplementary to both of those. And since those two angles are congruent, that makes sense. All right, moving along to rectangles. So all the properties of a parallelogram apply by definition. So all of these, all five of those, apply to rectangles. Okay, and that's what that means by definition. Since a rectangle is a parallelogram, all the properties of a parallelogram that we've already stated also apply to rectangles. The other thing is that all the angles are right angles. Okay, so make sure that, well, that's pretty much a given. I'm sure you guys know that, but that's the additional property you would have here. You would also have that the diagonals are congruent. So ET is congruent to RC. All right. Excuse me. Moving along to kites. Okay, two disjoint pairs of consecutive sides are congruent by definition. So that would mean that disjoint means, see this here? That kind of separates them. So IK is congruent to EK and TI is congruent to TE, but they are not congruent to each other. The diagonals are perpendicular. So that means all these angles on the interior by the diagonals are right angles. One diagonal is a perpendicular bisector of the other. So the longer one, it's almost always the case, the longer one is the perpendicular bisector of the shorter one, which means we already know that they're right angles, but it also divides these two, it divides this segment here into two congruent parts. One of the diagonals bisects a pair of opposite angles. So the long diagonal bisects these angles. So angle KTI would be congruent to angle KTE, and also angle IKT is congruent to angle EKT. One pair of opposite angles are congruent. So if you look, whatever angles aren't bisected, the opposite angles are then congruent. Angle I is congruent to angle E. And I say angle I congruent to angle E. Let's make that look more like an eye. Okay, but notice these are not bisected. And notice these don't necessarily have to be congruent. In fact, if you took a close look, you'd see that this angle here and here are not congruent in this figure. Okay, these three through 5, are sometimes called half properties of kites. And the reason for that is because it only applies to half of the figure. Only 2 of the 4 angles are congruent. Only 2 of the 4 angles get bisected. Okay, so that's just an example of those. So those are sometimes called half properties. Properties of rhombuses, all the properties of a parallelogram apply by definition. So anything that we say about parallelograms, we can also say about rhombuses. All the properties of a kite also apply, and the half properties become full properties. So, for example, angle M would be congruent to angle H. And because it's a full property, angle R would also be congruent to angle O. The diagonals would bisect each of the angles. So the diagonal between R and O would create MOR is congruent to HOR, and MRO is congruent to HRO. And then angle RMH is congruent to angle OMH, and angle RHM is congruent to angle OHM. You get the idea, though. I'm not going to write all those down. All the sides are congruent because a rhombus is an equilateral. There are your diagonals. So like I said, maybe you can see the angles being bisected a little bit more. And what else do you notice? The diagonals bisect the angles, like I said. Diagonals are also perpendicular bisectors of each other. So the diagonals create a perpendicular intersection here, and this would be congruent to this. This would be congruent to this. Let's differentiate here a little bit. Okay? And the diagonals divide the rhombus into 4 congruent triangles. So let's take all that out for a second, and if you look, if this is one triangle, okay, the same can be said. We could say that there's 1. Here would be 2. This would be 3 in here. And this would be 4 in here. So all 4 of those triangles that are created are congruent to each other by definition of a rhombus. Now, square has all the properties of a rectangle by definition, all the properties of a rhombus by definition, okay, also parallelogram, obviously, and the diagonals form 4 isosceles right triangles, and these are 45, 45, 90 triangles. So if we have a square, we know that that's congruent to that. This is a 90-degree angle. Okay, and how is that useful? Well, if you've got these 2 angles that are congruent, those 2 are congruent. Right away, if you have a square, you can prove any of these triangles congruent to each other by, if you look just at this side angle side, you can do all kinds of different things. So just for you guys to kind of see how this stuff is useful in a proof. Again, no theorems included, though, but you're extremely happy about that. All right, properties of an isosceles trapezoid. Last one. The legs are congruent by definition. We kind of knew that, though. So if I label this A, B, C, D, AC would be congruent to BD. The bases are parallel by definition of a trapezoid. So we could say that AB is parallel to CD. The lower bases are congruent angles. Now, that's only in an isosceles trapezoid. So angle C is congruent to angle D. The upper base angles are congruent. That would be angle A is congruent to angle B. Okay, not to each other. So lower angles, congruent. Upper angles, congruent. And that's only in an isosceles trapezoid. The diagonals are also congruent. So CB is congruent to AD. And any lower base angle is supplementary to any upper base angle. So angle A would be supplementary to angle C or D. Angle B would be supplementary to angle C or D, and vice versa. So you get the idea. Now, I'm not going to throw a proof at you at the end of this video because I know it's a lot to cover, but make sure you know them, because when you work on this in class, I will not be there, unfortunately, when you go over this. So I'll make sure the teacher has the answers, though. So do your best. If you have any questions, save them for the next time I see you so we can review it for the quiz. Okay? Have a lovely half day, guys, and I will see you when I see you.